Greetings, nerds. So this is a quick video about color theory. I'm not going to be explaining color theory as a whole here. I'm going to be explaining the problem with color theory and the stuff that you typically learn. So this right here, this is from Shepherd Color, their pigment supplier. This is not the full space of pigments. This is just what they sell. But as you see, it's a 3D model. A lot of the times when you're learning is colors on a 2D plane when that's not how they work. They work in a 3D plane where they have different branches of going up and down through chroma and different tints, different shades. Now, this is a really huge key thing here. And honestly, this is one of the few interactive ones you can get online. So this gives you an idea of how the colors are going to interact and how they're going to look. The correct type of color wheel you want is actually going to be a C-Lab wheel. This one is from handprint.com. Handprint.com is a phenomenal website when you're trying to get any information about this stuff. Bruce McEnvoy has been a godsend to the community, especially the artist community, for a very long time now. And this right here really does help. It is missing a few things for modernized pigments like Yinmin Blue. However, this is really good for commercial pigments and understanding commercial pigments. As we can see, this uses the CMY theory, quinacridone magenta, contrast phthalo green blue shade, not yellow shade. So on there, when we go with an actual red, it complements teal or turquoise, things like that. Turquoise is effectively just a desaturated teal when it comes to pigments. It's a little bit more towards the blue spectrum, but not that much more. Cobalt turquoise, phthalo turquoise, PB16, is going to complement up to orange. Blue complements yellow. Cobalt blue, more towards red, is going to complement actual yellow, that cool tone yellow, things like that. Violet complements green as well. This is the actual color space you're wanting to look at. The type of color theory that most people learn is the Iton theory. The Iton theory is 120 years out of date. It is a really bad system that doesn't work. So when we're looking at this, we have to also remember that the pigments used on here are not produced for the most part. Cinnabar here, that's cinnabar. That is a version of vermilion. That is mercury sulfide. We don't have pigments that replicate it very well. Their version of blue as well typically is based around Prussian blue. Prussian blue you do not find in acrylics as a single pigment, only as hues, because there is a risk of it turning into cyanide gas. Now, in the US, we use a different color theory called the Munsell system. The Munsell system is still fairly correct. However, we're teaching an outdated model of it. Back when he believed that orange wasn't a color and he called it yellow-red. Now, one thing here is that that's really important when you're trying to look at this is that our reds are complementing green here. However, red is complementing blue-green, complementing cyan. That would be the blue-green. This is a huge key to learning actual color theory. The Munsell system is more correct than Iton, but it's still out of date and it doesn't really work with modern pigments. Modern pigments are heavily based around the CMY system. That's all that is. Hopefully this was educational and I can get my gripe out of here. Also, one thing, the Munsell system, yeah, it's a 3D plane, unlike the Iton system. For high chroma and high saturation, low saturation, etc., etc. The value goes up, the chroma goes to the side, hue spins around. That's about it. Either way, have a good night or whatever, and bye.